Good morning, students. Today we are going to do topic of decoders. In our last class, what we have done, encoder and its types. So decoder will do the same function but in the reverse of encoding. As we know why we need of decoding in that type of application where data multiplexing, rate multiplying or digital display are used. So computer will not understand our language, so we need to decode our language into the computer language. Decoder will convert binary information to active output signals. Let's suppose we have n input lines or n input signals, and to find out the n input we use the formula of 2 raised to power m is equal to n, where m is equal to the selected lines or selected inputs, and here n is equal to number of inputs. So if I'll say the types of decoder, in encoder we have done octal to binary and binary to BCD, right? But in the case of decoder we have only one type, which is 3-line to 8-line decoder. So in 3-line to 8-line decoder, as we can see, 3 is number of input and 8 is output. So there is no need to make the to find out the selected lines. So we need to do only functional diagram. So in functional diagram, 3 to 8-line decoder, 3 lines in input, and I am denoting the inputs with A, B and C, and 8-line decoder. As it is decoder, so I am denoting the outputs with the D, starting with the D0, D1, D2, D3 and up to D7. D7 because we have 8-line decoder, 8 outputs, so starting with D0 and end up with D7. Now need to make its truth table of 3 to 8-line decoder. So firstly, inputs are A, B and C. So to make the inputs, we are following the rule of 4 to 1 method, and 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 111. As you can see, firstly we make 0 and then 1, then 2, 3, 4, 5, 6 and 7. So our inputs are ready. So to find out the outputs, which is D0, D1, D2, D3, D4, D5, D6 and D7. So when inputs are 0, 0, 0, in this case only D0 will be active. You can write it here as 1 or D, that totally depends upon you. I am writing here 1, which will be going to active, that will be mentioned by 1, rest all will be 0. So firstly it was 0, 0, 0 and then D0 was active, then it is 0, 0, 1, then automatically D1 will be active, rest all will be 0. 0, 1, 0, 0, 1, 0 is 2, so D2 will be active, rest all will be 0. 0, 1, 1, which is 3, and here D3 will be active, rest all will be 0. Same will be following in the case of 4, 5, 6 and 7. Last is D7. D7 will be active, rest all will be 0. So here is the truth table of 3 to 8 line decoder. So now need to make its schematic diagram or circuit diagram. A, B and C. What we have done in encoding case, the outputs we represent in with the OR gate. So here we are going to change a little bit. The outputs we are going to represent with the AND gate, because here there is a case of multiplication. As I am going to represent A, B and C, there are 3 input lines. So firstly is D0. In the case of D0, A, B, C, these all will be 0, 0, 0. So to mention or to make the 0, we are using inverter gate or NOT gate, and by combining all these, AND gate is going to use, and this will make A bar, B bar and C bar. In the case of D1, in the case of D1, A is 0, B is 0 and C is 1. So A is 0, so we are going to make inverter gate here again. B is 0, NOT gate or inverter gate, but in this case C is 1, so there is no need to make inverter. And by combining all these, D1 will become A bar, B bar and C. 0 is equal to bar, 0 is equal to bar, but C is equal to 1, that's why C is mentioning as it is. D2 is equal to 0, 1, 0, 0, 1, 0. So A will be 0, A bar, B is 1, So B is writing simple, no need to make any inverter gate here, and C is 0. For 0 inverter gate is going to use. So for combining these we are using AND gate. Then D2 will become A bar, B, C bar. So with this method D0, D1, D2, D3, D4, D5, D6, D7 gate will make, and your decoder topic is over. Thank you.